Hey everyone, Mick from New South Wales DPI here. Sorry I can't make it down there this year. Instead, we've just got a short presentation here for you on our soil CRC project, developing tools and knowledge to better manage herbicide residues in soil. Collaboration with a number of different organisations from around the country, including a couple of universities and grower groups. And what we're trying to do is better understand how herbicides behave in soil and develop tools to manage those herbicide residues so that we're not suffering from crop losses and plant back issues. And you can see an example of a plant back issue here. Suspect is clopyralid causing damage to these faba beans, but the diagnosis is not of the culprit's not 100% clear. So we're trying to improve on that. And we're asking, can we test soil prior to sowing to make decisions about what to sow? Can we test plants if we do see injuries to diagnose what the issues are? And can we better predict herbicide breakdown in different soil type climate combinations? We're looking at a number of different priority herbicides, including the IMIs, clopyralid, diuron, and pyroxasulfone or Sakura. And they all have different chemistries and behaviours in the paddock. One of the issues for growers is that if they do suspect that they might have residues in soil, they can send a sample away for testing and they'll get a number back, but it's very difficult to interpret what that number means. That's because there's not many publicly available toxicity thresholds to compare against. So as part of this project, we try and develop those toxicity thresholds, and I've got an example here of one of our experiments where we looked at field pea grown in sand in response to increasing clopyralid residues in that sand. From that, we can define an ED20, which is an effect dose at which 20% biomass is lost, of 0.6 micrograms per kilogram in this case. And we've repeated that for a number of different soil types and a number of different crops. So you can see here 8 different crops growing in response to increasing clopyralid concentrations in soil or in sand. And the thresholds are quite low for sand because there's no binding of the clopyralid, whereas in these soil types with increasing clay content, some of that clopyralid's bound up and it's not actually bioavailable to the plant. And so you can see the thresholds actually increase for the soil types. You can see of the pulses, lupin's probably the most tolerant to clopyralid residues compared to things like lentils, which really aren't tolerant, they're quite sensitive. We've also been measuring clopyralid persistence in soil at different Eyre Peninsula sites, at 5 different sites. Here's an example from the Minnipa site where we measured 8.5 micrograms per kilogram in the soil at the start of the 2019 season. And after barley was sown, clopyralid was applied on the 25th of June. And you can see here in the top soil, these white dots, this is when clopyralid was applied, and you see an increase in concentration as the clopyralid's washed into the soil and break down over the following year. Interestingly, at another site at Mount Cooper, we had a similar amount applied of Lontrel on the 4th of July, and in this case, you can see a lot more rapid breakdown in this soil with more organic carbon and clay and more rainfall. Interestingly, though, after 100 days, we're seeing an increase in clopyralid concentration in the soil, and we think that's because of breakdown of some of the crop material and eventually the crop stubble, which is re-releasing clopyralid back into the soil. So we've got a case study here where clopyralid was suspected of affecting these lupins. So here's a better looking plant and a poorer looking plant. We measured the clopyralid in soil. There was 3 to 8 micrograms per kilogram, which was less than our thresholds for lupin. However, when we measured the plants themselves, we did find quite a lot of clopyralid. So what we're hoping to develop is thresholds for residues in plants as well as soil. And we're linking with a number of different CRC projects to increase the reach of this project. And if you want to go to this link, there'll be more information about this project on a longer webinar. So thanks for all your contributions, and we hope to give you more information about this project soon and hope to continue the collaboration. Thanks very much.